This is the video demonstration of exploit development Coursework 2. So first we'll see the file. Okay, we have here Coursework 2 file. So we will see LDD and see what is the file about. So here we can see the LDD command displays what version of BDSO file image it's using, libc version and LDB version of the Linux. Okay. So while we are doing in exploit, it is running in Docker. So we need the libc file and loader file from the Docker. So okay, this command gives the libc file which we need to exploit the code and the LD file too. So by this command we can extract the libc and LD file. Uh, so I have already extracted, so that's successfully copied. So similarly, I have successfully extracted the libc and LD file both. So we will be further moving for uh, the patches. Before than that, uh, we will be setting the randomization off while we hit this command. Sorry, we can see here different addresses being shown. So for that, we will be we will be disabling the randomization. Echo 0 sudo okay. So we can see here our randomization has been disabled. Moving further, we will be patching the file with pawn in it. So here we can see we are using the custom libc custom libc file which was extracted from Docker, and a custom LD file which was also extracted from Docker, and compiling it with the binary CW2. So in this way, it uses the libc from the extracted file which we extracted from Docker. So we have already received the CW2 patched file. Okay. So here we can see the file which is patched uses the libc from our custom library and LD from our LD from the same. However, the Coursework 2, which was not patched before, the initial file uses the system libc. Uh, so moving further, I have loaded it into the Gitra and named some of the functions. Uh, these are the functions. I have modified main functions, booking function and admin function. Some of the name of the functions were also modified. So I have named some variables like character usernames and user inputs. So that will be easier for us to read and identify all the vulnerabilities. Here, this part, the username is directly getting the input. So it is being directly taken from a user. The printf passes the input from user directly. So let's run the patch file. So what we have done here is entered some percentage p. uh, we have identified the formatting string vulnerabilities from this point, as the printf directly takes the username user input. So we are passing here uh, percentage p. Okay, and we exit the program. So here we can see the leak. It is showing the leak while we exit the program. So we will move forward to the admin function. Here we can see here is a read 0 local p8 and 0x 100. Okay, so the read function takes 0x 100 as input. So we'll see what is 0x 100 here. So as we can see here, 0x 100 is 256. So what we can see here is local p8 is storing 112 bytes here, but the read is taking 256 bytes. So the local function have 112 bytes for storage. However, user input is greater than 112 because the value x 0x100 is 256. So here is a buffer overflow at this point. Uh, so here we can see I have entered the name and book a device. So here is the quantity of the book. So for now I will be entering to enter the quantity. So I want to enter the quantity about 80. So yes, and now we will be yeah, we have requested for admin. So we'll be putting here a random thing. For now I'm keeping it my name. Okay, for the reason part here we can see here it takes the input from user. So the new reason takes the new data from this part. Okay, the read take input from user and store in local 8 function. Now, so we will be seeing here buffer overflow vulnerability. Let's give the value is more than it. So more than it is 300 because of 256 bytes being stored in this point. We will be passing more than 256 bytes, which will eventually cause the buffer overflow. There is another bug here too. This part is the another bug. So local 8 only store. Okay, so here read 0 local 48 have 0x40 value. So we'll see what is 0x40 right now. Uh, so here we can see 0x40 is the hex value of 64. So we can see here it takes 64 bytes as input. So For the input, it uses add, but does not add null terminator here. So the system use local 48 slash n for program, so that the program uses as var10 slash 0, this one. So the program is using slash 10 and slash 0 as the null terminator. So to fix the code, uh, the program is trying to fix the code by new line with terminator slash 0, but it's not working fine. So furthermore, if we see here, so we will be running the file again. Enter random name, book a book, enter more than 50. Yes. So we need to enter the name of item. So for now we will be entering more than 64 bytes. That is, okay, we have entered the code, I mean cyclic pattern, and so we have here, we can identify your leak. uh, so we can see the leak here because it doesn't append or null terminator in the end of the cyclic pattern, but it is trying to fix by entering 0 slash 0. So it's not working properly, and we are getting the leak. So once we will be trying to enter cyclic 128, which is double the value of 64. So we will be again so we have here enter your need. I mean, sorry, contact your admin and enter your need. Okay, so if we are checking whether the value is greater, the greater value will leak greater pattern, or I mean greater leak or not. So we have entered this cyclic 128 here and entered. We can see here we have the two leaks here, one here and one here. These are the memory leaks from the program. So we need a leak of the libc by using the vulnerability of printf format string vulnerability. We can we can get the leak of the libc. Here we can see here username is the program is taking rbp plus minus 20x20. Rex is stored in the variable called username, right? So we will be loading the file in gdb. Okay, we have successfully loaded the file. We'll run it, enter our name. Okay, our choice is to book a device. Okay, 180 quantity more than 50. My choice is 1. Okay, a random thing. Okay, now we will be hitting the Control C button in order to analyze the value. So first we will be entering cyclic 300, as we have the vulnerability that takes 256 character in the admin part here. See, just wait a minute. Okay, this part takes 256 characters, so we will be trying to buffer overflow for this character. Okay, since we have entered the cyclic pattern here, we can see here buffer overflow leak here. This is the point where the buffer overflow has been started at the register RSP. So we will be calculating the leak cyclic hyphen L. Okay, from here we have found uh, offset 184. Now furthermore, in Ghidra, the main function print username. Okay, there is a format string vulnerability. So here we can see uh, the format string vulnerability, which mean only buffer overflow, and so we can see here. So the username in the username function or the username function, the uh, value is being stored at RBP. While I use RBP to modify the RX for, value, furthermore modifying RDI, that might help me. So let's have a look for gadget. So we will look for pop. Mm, pop functionality. So here we can see pop RBP and red gadget there is written here. So there is a gadget. We have here RBP which modify RAX, uh, and furthermore modifying RD. So this can be used to change the value. So we can see here the offset of 1213. So furthermore, what we are going to do is uh, we will be seeing now the wrapper. Okay, since we have already searched this, now we will be seeing for the slash bin slash sh cell. So we will be doing here wrapper hyphen strings. So we'll search for string slash bin slash sh hyphen f libc. You can see the slash bin slash bash address here. So now we will be searching for pop address. We have searched for here pop address here. Okay, we will be using rob gadget for pop RDI. This was for pop RBP. Now we will be searching for pop RDI. So our command will be rob gadget binary libc grep. So for the pop address, uh, here we have seen the output. We need 4 type of address for this here. So here we can see the pop address with the rate RDI, this one. So now we will be seeing for system address. So we can see here the address of system. We have already found the address of bin, the pop RDI rate, and the system file. Now let's see our exploit code. So we can see here exploit code. Okay, let's have a look towards our exploit code. This is a Python-based script which is exclusively written for return-oriented programming, which is an exploit framework. So, okay, what this does is first we will be seeing what it does. Okay, it connects to remote binary service, leak memory, and calculate libc automatically. Construct a ROP chain to execute bin bash and spawn cell. Okay, so what we have used, we can see here import struct and import time, import pawn import. So struct is for packing unpacking binary data, time is for delay and time calculation, pawn tool is for exploitation framework used for remote connection, payload building. So this is it. Okay, furthermore the context architecture and error and the split, they are used for 64 bits. It is used to define the 64-bit architecture. This error is used to hide debug, hides debug log. Okay, error only will be here. Okay, specific. Now this context terminal uses is for specific, uh, is specifically how to launch an interactive cell in tmux. So furthermore we have your class. Okay, this we have so many, we have set the target and the port, as we will be running the docker, and which will be the target for exploitation. So this stores the target data, prepare variable to hold leak data and hold uh, payload and chain. See here we have the target port, which is especially designed to leak data, I mean hold data and leak addresses. So another is connect to target. So this will uh, this is specifically used to connect user remote server, that is Docker, from pawn tools to connect the vulnerable service. Okay, if successful, it stores the connection object. It's simple. Okay, so next one is bypass authentication. So give me a minute. So what this does is send a series of input, which is menu option and password label. This is the menu option, password label, and all. This is the option, uh, and it evaluates in send line by line with a slight delay. So we have the we use the time for delay. This is also used for simulating and navigating through the menu to reach the vulnerable point. Uh, so furthermore, so this leak memory address is used for sending crafted buffer overflow leaks. Wait for the response and grab 6 bytes. 6 bytes that 6 bytes leaks. Pad it with 8 bytes, and finally unpack the leak and addresses. See here we can see the leak and addresses. So furthermore, the memory disclosure leak address. Okay, so this would probably, now furthermore the derive one, this is used to subtract the known offset from leaked address to find the base of libc, and this is crucial to find the real address of system and bin bash. So this is specially used for that. And the setup the ROP chain function. So why is it is used is to hardcode ROP gadget offset for the known libc version and calculate their memory location. So purpose of this, all of these payloads are to fill the buffer and overwrite the return value, append the crafted drop chain that uh, load bin bash and call system gives. So final, so this transmit, what does this transmit payload does is by repeat bypass and send the final payload. And this diff execute exploitation. So what does this part does is run all the steps in sequential manner and end with interactive cell. Okay, so see here we can here end it interactive shell. So this is it. Here we have been calling the main function. Now we will be running the Docker file. So this is the command to run the Docker file, which is the remote server hosted in local host. Now we will execute the exploit. Okay, so this demonstrates that we have successfully acquired the shell.